Hello students, welcome to another video. In this video, we are going to see the question number 18 of GATE 2022 question paper. According to question, in fluid flow, the dimensionless number that describes the transition from laminar to turbulent flow is options are Reynolds number, Schmidt number, Biot number and Prandtl number. First of all, we will see the concept for all of these options, then we will take the correct option. First one is Reynolds number. Reynolds number is defined as ratio of inertial force to the viscous force. This is used to determine whether the flow is laminar or turbulent. Formula for Reynolds number is Re equals to rho Vd by mu. In this case, rho is the density, V is the velocity, this is the characteristic length, and mu is the dynamic viscosity. Option B is Schmidt number. Schmidt number is a dimensionless number that represents the ratio of momentum diffusivity to the mass diffusivity. And this we can write, for momentum diffusivity we can write kinematic viscosity nu divided by mass diffusivity, that is d. And further we can write, for kinematic viscosity we can write mu by rho, that is dynamic viscosity by rho divided by mass diffusivity. It compares the relative thickness of velocity boundary layer and mass diffusion boundary layer. Schmidt number is high for liquid like water, where Schmidt number is greater than 1, and Schmidt number is less for gases, where Schmidt number is less than 1. For example, we can see for air Schmidt number is 0.6, for water it is 600, and for oil it is 1000 plus, this is more than 1000. Option C is Biot number. It is a dimensionless number that compares internal thermal resistance of a solid to the external convective resistance at its surface. It is mainly useful in transient conduction problem. With the help of formula, it can be written as Biot number equal to HLC by K, where H is the convective heat transfer coefficient and its unit is watt per meter square per Kelvin. LC is the characteristics length in meter, and K is the thermal conductivity of the solid in watt per meter per Kelvin. For practical application, if Biot number is less than 0.1, that means the conduction inside the solid is much faster than convection outside. So conduction is much faster than convection. For the Biot number greater than 0.1, there is a temperature gradient exists inside the solid and the internal conduction must be analyzed. This is used in unsteady state heat conduction problem. It helps in designing heat exchanger, electronics cooling, thermal insulation. Now the option D, that is Prandtl number. Prandtl number may be written as the ratio of kinematic viscosity to the thermal diffusivity. This may be also written as hydrodynamic boundary layer to the thermal boundary layer. For the ratio, we can write kinematic viscosity, that is nu, by thermal diffusivity, that is alpha. We can also write kinematic viscosity as mu by rho, that is dynamic viscosity by rho, alpha, that is K by rho Cp. For practical application, air has a Prandtl number of 0.65 to 0.71, water has 2 to 6. Now we have gone through all the concepts of the 4 options. Now we can take the correct answer, that is transitions from laminar to turbulent flow. For the option A, we have seen that to study the laminar and turbulent flow, we have the Reynolds number. So for this question, option A would be the correct answer. Hopefully you liked the video. If you did, please like, share and subscribe the channel. Thank you for watching.